Since our beginning, mankind looked up to the stars and dreamed of one day visiting other worlds, seeing what was on other planets, and planting the roots of humanity throughout the universe. Interplanetary living and travel have been deeply ingrained into our culture, with many pieces of science fiction involving the travel and living between and on different planets. Mars, in particular, has been the focus of many works of science fiction, describing and dramatizing what it would have been like to live on the red planet. What these works typically do not address is what challenges and obstacles the characters had to overcome to establish a livable colony on Mars in the first place. The sheer amount of differences between our planet Earth and the red planet Mars present many problems related to the livability that aren't faced here on Earth. Aside from the obvious differences in color, there are 1,001 facets about Mars that make Mars unlivable without the proper scientific solutions. Perhaps the most obvious and well-known challenge facing would-be colonizers is the lack of water on the Martian surface. On Earth, water was instrumental in the development of early civilization. Without exception, every early civilization developed around a source of water. Early Mesopotamian Sumer around the Tigris and Euphrates, Egyptian society around the Nile. All human life revolves around the presence of water to aid in agriculture. Mars, as is obvious by its red appearance, is obviously lacking in usable water on its surface. This presents the clear and obvious problem for would-be colonizers, for whom the lack of water would prevent any day-to-day farming activities. While NASA has confirmed the existence of flowing liquid water on the Martian surface, almost all of it is at the polar ice caps. Now, it's an important distinction. The ice at the polar ice caps isn't actually water, it's actually dry ice, which is made up of frozen carbon dioxide. The real water is actually under the ice caps. So it wouldn't just be a matter of settling at the poles and melting the ice. A settlement at the poles would have to pump up the groundwater in order to use it. Simple enough, right? Except no. Living at the poles brings us to another problem with Mars, its temperature. The temperatures at the poles, where the water is, can easily go to negative 225 degrees Fahrenheit. Not particularly livable. The temperature differences would result in problems with temperatures with both the human body and the structural materials that are used in the colony. Along with all of these problems related to water, another question and obstacle are revealed. What would the colonists even do for nourishment on Mars? Well, one option is to receive perishable shipments from Earth on a regular basis. That idea is expensive and would become quickly unsustainable when the colony grew in size. Instead, the colonists would eventually turn to farming. Farming on Mars has been dramatized in the recent film, The Martian, where stranded astronaut Mark Watney must grow potatoes in the Martian soil in order to survive on the planet as he waits for a rescue. The film has some interesting accuracies and inaccuracies relating to farming. In the film, Watney uses normal Martian soil, fertilizes it with real human waste, and waters it from the resulting water from the combustion of leftover rocket fuel. Watney's endeavors are technically feasible for only one reason. He didn't actually use water from Mars. Instead, he used water that he himself created. You see, the only real problem with farming on Mars is the water, not the soil or the fertilizer. As you can see, Martian soil has all of the essential nutrients for healthy plant growth. The only issues are the potentially large amounts of perchlorates that could be present during growing, which is a health issue for humans that are eating the produce. Perchlorates are found on Earth and are a problem with farming here as well. The EPA even regulates the amount of perchlorates that can be in our food because they can lead to problems such as hyperthyroidism and even cancer. Exposure to such a carcinogenic substance is extremely dangerous, but have to be addressed in the future should Martian agriculture actually become a reality. The thing is, perchlorates are much more common in Martian water than they are in Earth water, which means that normal water from Mars would need to be treated before it would be safe to use in agro. While the soil also has high amounts of perchlorates on Mars, good fertilizer can get rid of them. The only real problem, again, is with the water. This toxic water is a severe hazard to any sort of settlement, which is why, along with finding a method to gain access to large amounts of water, which is already tough enough, as previously mentioned, a method to efficiently treat perchlorates must also be found and made readily available to any colonists. While these issues regarding food and water may be the most pressing, there are many other miscellaneous problems facing potential colonies and colonizers that would severely jeopardize the success of the expedition. These include problems with gravity, planet size, and even overall terrain. Firstly, gravity on Mars is much weaker than on Earth, which would have some unforeseen consequences. Astronauts coming from long-term exposure to zero gravity experience severe muscle and bone atrophy due to the lack of stress on the body, which makes adjusting to Earth gravity again very difficult. These issues, particularly the bone atrophy, take astronauts an extremely difficult